My name is Oluwapomile Afokwe, and I am a graduate student of Mechanical Engineering and Electrical Engineering, studying for my doctorate degree at Iowa State University. Today I'll be showing us how to build an electromagnet, and I will be taking us through the theory of electromagnets, and also we'll get to do some hands-on activity. An electromagnet is a magnet that runs on electricity. It is different from the permanent magnets, like the usual bar magnets that we know, and its strength is dependent on the amount of electric current allowed to flow through it. On a general note, magnetic fields are produced in current-carrying conductors. And so it's the simplest electromagnets you could find around is a coil of wire wrapped around an iron core, like you can see in the picture below, where you have a nail with coils of wire wrapped around it and then connected to a battery. So before we go forward, let's define what electricity is. Electricity is as a result of the movement of electrons within materials along a continuous path. And for electricity to flow, we need an electric circuit, which includes a source, like the batteries, a conductor, like the wire in this case, and an object. And so electricity will only flow in a closed circuit, which is unbroken. Talking about magnetism, magnetism is the pushing or pulling force around the magnet, and this is usually experienced in the presence of a magnetic field. An object attracted by magnets would usually contain iron, cobalt, and nickel. Temporary magnets can be generated using permanent magnets or electricity. And so today we'll be learning how to build a temporary magnet using electricity. All right, before we get started on the hands-on activities, let us look at the applications of electromagnets. We would find electromagnets in motors and generators. Usually if you open up your generators, you find coils of wires wrapped around iron cores and wound into solenoids. We also find electromagnets in electric bells, in our loudspeakers and headphones. Electromagnets also find its use in the industry for magnetic separation equipment. So usually if you want to separate metallic materials from non-metallic materials, you could make use of electromagnets. And also in industrial lifting, you could use electromagnets to lift heavy metallic structures. Finally, electromagnets also find its application in medical applications, one of which is magnetic resonance imaging, shortened for MRI, and also in transcranial magnetic stimulation, which is my current research focus in grad school. So with transcranial magnetic stimulation, you have coils of wires positioned over the scalp of a patient to treat neurological and psychiatric disorders. And so with that coil of wire and a principle known as electromagnetic induction, you have magnetic field generated in the coils, inducing electric field within the neurons of the brain. And with this, treatment can be administered to such a patient. All right, what materials do we need for our hands-on activity? We need a iron or steel bolt of about 2 to 3 inches in length. We need metal paper clips. We need battery holders, which we can improvise with masking tape. We need copper wire of about 30 inches in length. We need a wire cutter to cut the wires. And we need 2D cell 1.5 volts batteries. What are the precautions required for this activity? We need to unplug our wires after the activity, as they become warm if they remain connected for a long period. We also want to keep our magnets away from computers and storage devices. We also want to disconnect our wires from the batteries at the end of the activity, so there is no risk for fire hazard. So what are the directions in building an electromagnet? You get your steel bolts and wrap your wires around it. So this is my copper wire. I source all the materials from Walmart. So everything required for an electromagnet is something you could easily source from local store around you, and then you wrap your wire around the coil. You want to ensure that it's evenly spaced and it's tightly wrapped around the bolts. And so when you do that, you ensure that you also leave some little space just at the end of the bolt to allow for proper connection. Since I do not have a battery holder, I have decided to improvise for my battery holder. So I have my batteries, my 2D 1.5 volts batteries, my 2D cells 1.5 volts batteries, and then I have just a small length of wire that I had cut from an old electronics, and I can connect the positive. How do you recognize the positive side of your battery? You can see just here on the battery written positive. So the plus sign indicates the positive side of the battery. And so I connect the positive side of my first battery using my masking tape to the negative side of the second battery. I also use my masking tape to do that. And so this will serve as the source of our electricity. And so the coils I have formed around the bolts, I want to connect it to the batteries. And so I would do that by connecting one end of the wire to the positive side of the battery, of the first battery. So I connect one end of my wire to the positive side of my battery, and then the other end of my wire, I connect it to the other end of the battery that is not connected. So you have it as the negative side, so that you have this setup. I will just arrange that properly. And so you have a setup like this. First, you have connected the negative side of one of your batteries to the positive side of the other battery, and then you connect your wire, one end of your wire from the bolt, one end of your wire to the negative side of the battery, which you have the positive connected to the other battery, and the other end of the wire you connect it to the negative side of the battery, which you have its positive side connected to the other battery. So you have a setup like this. And then after doing that connection, you want to test your electromagnet. You have an electromagnet already, but you want to test if it's working. And one way of testing that is by trying to use your bolt to pick up paper clips or any other mails that are around you. But because we have just a 1.5 volts battery, we could just use it to pick up paper clips. Alright, so that will be it for Build It Electromagnets. If you want to troubleshoot your connection, in case you're not able to pick up any paper clip, you would want to check your connections and ensure they are tight and that your batteries are not dead. You want to check that your wires are firmly connected to the batteries and the batteries are both connected to each other. And so for another challenge, to increase the strength of the electromagnets, there are two things you can do. One is to increase the number of coils around the bolts. You want to wrap more copper wires around the bolts. And another thing to do, the second thing to do is, you could add more batteries to the circuits so that you have more current. More current flowing through the circuits. Thank you for your time. If you would like to contact me, if you have any questions, I have left my email address on my introduction page. And that will be it. Thank you for watching.